GM, here we are. It is camp episode 4, steamrolling through the camp series. This is midway now. Episode 4, we have Max from Everclear and Ryan from Across Protocol, and jumping in on the SEDA side is our CEO, Peter Mitchell. Great to have all three of you here. Thanks for your time. As always, we'll kick off the episode with a little round of introductions. So if you could just intro your name, your position, and the product you're working from, and a little moment to shill what it is you guys are doing. Ryan, if we'll handball over to you to start, please.
Yeah, great. Great to be here. Thanks for the invite. I'm Ryan. I'm the product lead for Across, and we are building this intent-based bridge, intent-based interoperability protocol as a kind of different paradigm to your typical message-based bridging applications. And so we've seen a lot of success here in the past year, and eager to discuss kind of what the future holds with this team.
Awesome, man. Just a quick question too. You guys weren't specifically building for chain abstraction as well, right? You just built this tool that happens to be super powerful for chain abstraction.
Yeah, I mean, we think a lot about chain abstraction. It kind of involves, I think, a wider stack. At the presentation layer, UI, wallets, apps, and so we are definitely eager to figure out how exactly that all fits together. But we don't have a specific product that we would call a chain abstraction at the moment.
No, amazing. Can't wait to rip into it. Also here we have Max. Looking forward to handing over to you as you're trailblazing your own layer in the stack that Ryan was just talking about. So please
yes, GM everyone. Glad to be here. My name is Max. I'm the ecosystem lead at Everclear. I'm also an Arbitrum delegate. I've been with Everclear for the past 3 years. Actually, we used to be called Connext. Connext has been operated one of the oldest intent-based bridges, but we realized that all these intent-based bridges need some support with the solvers to rebalance their liquidity. And that's when we started to work on what we now call Everclear, which is the first clearing layer, basically a service for solvers and bridges to rebalance the liquidity in the most efficient way. We are part of this chain abstraction stack and chain abstracted vision, and happy to deep dive in during this session.
Well, we're going to have to deep dive into what you guys are doing because it's a part of the stack that a lot of people maybe didn't realize was there until we started talking more about intents and solvers, and then you guys popped up into the clearing layer. So very, very excited to dive into that. Peter, your first appearance here on the camp series, so it'd be great to get an intro to you and a little deep dive on SEDA as well.
Yeah, so thank you. I'm Peter. I'm the co-founder and CEO of SEDA. Great to be here with you guys. SEDA is Programmable Oracle Infrastructure. So basically allow anyone to deploy a custom Oracle feed for any data type across any network. So if you deploy a Oracle program to SEDA, you can call that from over 250 networks in our ecosystem and be able to basically call any data type from price feeds to chain state through RPCs, so important for intents, or any other type of data like RWA or whatever API, private or public that you wish.
Amazing. And just to set the scene here before we dive deeper into sort of chain abstraction, and we're diving deeper into the stack than we have in our previous 3 episodes. So just anyone listening in that's been on the education journey, Across is very much focused with intents and using their solver network for improving what was a traditionally incredibly complex bridging experience for users. Then we have Max from Everclear. Everclear is focusing on clearing, which we're going to dive into. And then SEDA is very much focused on kind of like programmable data and making day one data access just the standard across Web3. So very exciting to have 3 very different protocols here, all participating in the stack. If you do need a refresher on what that stack looks like, the rollup dropped the ecosystem map. I think it was 80 plus projects, all building towards this chain abstraction dream, which is not just for users, it's also going to be an absolute lifesaver for developers as well. We do this on every episode. We'll start off. I want to understand a little bit more about how each person's kind of thinking about chain abstraction. What does it mean to you, and kind of which piece do you believe is the most important or the sort of the biggest challenge that we have to solve right now? Again, Ryan, we'll throw across to you.
Yeah. So when I think about kind of the user journey, when Ethereum solved its scaling issues by growing the L2 ecosystem, that effectively, solved the UX of high fees on L1, but it created all this fragmentation. And so we just traded a UX issue of cost for a UX issue of fragmentation. And so, I think if we, want to compete with kind of these monolithic blockchains, or if Ethereum wants to compete with these monolithic blockchains with where it's all combined, we have to solve this fragmentation piece. And when I think about the user journey, users, they want to use applications. They don't necessarily want to use specific chains. They just have some goal in mind, and they want to use an application to achieve that goal. And on the flip side, developers, they ultimately want users to use their application. And so right now, it's like, how do you solve those two things? So users to use an application, they often have to go through this, multi 10-step process to go bridge their assets, know where their assets are, get them on the right chain where the app lives, and then do the thing they want to do. On the flip side, developers, they want to, attract the most users. And so if they're trying to attract users from different chains, the easiest thing for them to do is deploy to a bunch of chains. However, that creates kind of some friction too, because now as an app dev, I have to manage, deployments across multiple different chains. I'm fragmenting my liquidity, also fragmenting my user base. If I had, a higher percentage of users on a single chain, and to begin with, now I've kind of fragmented that. And so to solve those two issues, we think intents are a big piece of it. I think it's going to take other pieces though. And so what I mean by, where intents kind of fits into this chain abstraction landscape, I think, at the highest level, it's that a user wants to take an action in an application on a chain where they don't have assets. And an intent system like ours and like others, and even like the standard that we're creating with Uniswap, ERC 7683, it allows for intent orders to be structured that include, defines what the user wants. I want to move some amount of funds from chain A to chain B, and then perform an action on chain B, where that action is interacting with the application. And so that if this kind of works today, Across has this functionality. Other protocols, I think, probably have this similar or same functionality. So this all works. However, the challenge is, how do we embed this into the application? Number one, and then how do we go even further upstream and solve the presentation and UI layer issues for the users? Because right now they have to kind of know where assets live on each chain, because they have to select, what they want to what asset they want to use in order to perform this action. But I think the future in which we want to create is one where that doesn't exist. Users just use assets. They can live anywhere, and they just use applications with those assets. And whether they're on, multiple chains or one chain, it doesn't necessarily matter to them. Now, how do I think that's going to work? I think there's a lot of ambiguity and question marks around this. The further up we get to the stack and further closer to the user. And so I think standards help a lot with that. 7683 is potentially one part. I think 7702, once anything like any EOA can kind of function as a smart wallet, that brings an additional, layer of functionality that can start to enable this. But ultimately, I think we have to figure out how those two pieces work with the presentation layers, i.e., the application presentation and or the wallet presentation to the users. And so that's kind of my 10,000-foot view. Happy to dive deeper into any part of that. I do
want to ask you, I'm not sure, so clarify for me if Across is sort of focusing on the Ethereum ecosystem itself, just because that's where you sort of started what you were mentioning just then. When you think about abstraction, are you thinking about abstraction across the complete industry, whatever chain, any new chain, and new app chain, specialization chains, whatever it might be? Is that the end goal? Or I also like the way that you approach it. It's kind of like it's a step-by-step, right? We have to solve this problem and then we can solve these other problems. So is it better to focus on one ecosystem first before we abstract, the whole thing?
Yeah, so like in our history and across this history, we've been focused primarily EVM. However, we are exploring other ecosystems and trying to connect them. I think the end goal, 2 years from now, 5 years from now, we do see it where hopefully that users don't have to worry about what chain they are. That could mean an L2 in EVM land. That could mean Solana. you know, or any other chain in between. But I do agree. I think like we're not there yet. I think we have a lot to build as an industry and a lot of kind of collaboration with different parts of the stack to get there. And so I see kind of this intense model of I'm a user. I want to move my funds from chain A to chain B and then perform some action. That's like step 0 potentially. That's like we've gained some amount of functionality where we've reduced some complexity on the user, but we're not fully abstracted. You know, users still have to know what chain they're on, still have to know what chain the application's on, kind of all that. And so I don't know that how many more steps there are to abstract that fully away. But you know, I think it's going to be a, you know, interesting and fun process and collaborative process with all of the industry partners that we work with.
No, 100%. I also think it's super important that like people do need to get educated at some, like it's beneficial if people have to have some sort of education because that can help them become more bullish on an industry. I mean, it's great that if you can come in and just use an industry and not have to know what's going under the hood, but while we're in the process of going through these steps, I think it's great that those people coming in will have kind of less education than you needed a year ago, 5 years ago, but they'll get some kind of idea of why this whole industry exists. So Max, same question to you. What's sort of the chain abstraction part that you're the most bullish on, most excited about? And when you think about chain abstraction, what does that mean to you?
Yeah, I agree with Ryan in general. I think it's time also for the Web3 industry to really separate the concept of what is infrastructure and what is an application for the user. It's unheard for an internet user to having to think and know what type of infrastructure they're using, right? When they go on a website, they want to play a game, that's their purpose. They don't want to know how does it work behind the scenes, what server they're using, what storage, what type of storage is the website using, right? All of this is part of the infrastructure, and the same should happen in a Web3 world, right? So we're finally getting into this concept of abstracting fully in the blockchains, and part of it is abstracting the cross-chain experience, which is one of the most messy and chaotic one, derived also from the architectural decisions of creating modular blockchains, which, as Ryan was saying, fragment the liquidity, the users, the applications across the different chains. And so yes, the work that we are all doing is really trying to make the experience simpler for users, and the trend that has emerged as one of the most effective one to improve this experience is these intent-based systems, right? The idea that you are outsourcing really the complexities to a series of off-chain actors. We call them solvers. Some people call them relayers, whatever you want to name them. But these are really like entities that you outsource your intention to and tell them, hey, do this thing for me. And I just want the result. I just want to enjoy the final experience, the final output of what you have to do. Please manage it yourself. And so within this realm, that's where all the chain abstraction stack comes in. Like, how do we make sure that the user is communicating the right message to the solvers? The solvers are selected because they are the best ones to solve the specific problem, and then they can do it in the most profitable way, of course, because it's all like at the end of the day, it's all a game of how do I make money by serving the users in the best way. And so this is where the work of Connect, I think, has been doing in the past years. Side funny note, the term chain abstraction was actually coined by Arjun Bhutani, which is the Connect founder, a year and a half ago. And so that's why we've been deep thinking, okay, how do we make this fully off-chain economy really happen? When I mean off-chain economy, means this intent-based system that then translates the off-chain instructions into on-chain instructions. So how do we make that work? And that's where Everclear comes in. Everclear wants to make the solvers be as profitable as possible by making their operations really efficient during the intent lifecycle. And I think maybe later we can dive in how the intent works and then where the different pieces come in.
Yeah, I think also I hear a lot on the sort of community side, cryptosphere side, investor side, that there's a need for applications and like infrastructure is overdone, and that we need to keep building applications that users want to use. But I think the current state where we are today, we have a bunch of some monolithic chains, like Solana would be a good example of that, Ethereum, etc. Then you have so many rollups, so many sort of modular stacks that users can now integrate with. And having sort of this fragmentation of liquidity and user experience across wallets, across assets for users, I think that this is probably one of the biggest sticking points still towards getting applications that can really onboard users in a meaningful way. And I think that at SEDA, we sort of see the same thing, focus on the developer side, which is making sure data is available in a standardized way. But I think for the users, all the infrastructure that we're working on, especially Everclear on the liquidity fragmentation side and across on building, things like hooks for developers and intents. I think these are two areas that will really improve the user experience for the developer, which allows them to create a better application that users actually want to use. So I think both of these problems are super important to get to the point where we can really have applications be built across this infrastructure in a meaningful way for adoption.
100%. I think having these like ecosystem maps around chain abstraction and having these conversations that we're having, I mean, Particle Network, Zyma, they're all having, series at the same time. Chain abstraction mindshare has just gone through the roof across crypto Twitter. But I think what that's doing to the people demanding applications is they're starting to see, well, what's really under the hood here and why we don't have the applications. And the more that they learn about, solutions that Cross is doing, Everclear, SEDA, and all the other projects building for it, they're starting to realize that it's better just to, let's take the foot off. If we want Web3 as an industry or on-chain experience to really be adopted, it's like selling someone a horse and cart and then saying, but if you wait 5 years, I can give you a motor car. The experience in the motor car is just going to be so much better. So let's get all those pieces and parts together. Let's get them working and then have that experience. And I guess kind of if you were to really zoom out on chain abstraction, there's kind of 3 things that we need to really hit the nail on the head today in this conversation. There's intents for the user, developer, solvers underneath it, and then what's happening on the other side of the solver. So maybe that's a great way to go to you, Ryan, on intents. Why is Across so bullish on intents? Why do you think that that's the best option here?
Yeah, so when when I think around, so I guess I start kind of this, this part of my, my thoughts around at the highest level, rewind when bridging first started to be a need, or it, effectively it was all about moving value. I'm a user and I need to move value across chain. There is need to move data as well. But we think, the primary use case right now, and we think the primary use case in the future is going to be moving value across chain. So tokens, fungible tokens. And the historical way that has been done is, I have tokens on chain A, I send them into a contract or a pool, they get locked. I send a message from chain A to my destination chain B, and then those tokens get unlocked or minted in some way. And so the challenge is this messaging part, we think is, there's no really way to do, so you want this message to be fast, cheap, and secure. You want user to have to get their money really, really fast. You want it to cost very little for them, but you also ultimately want this thing to be secure because, you have 2 different blockchains that have different security assumptions that you don't want those things to break. And we think the messaging pathway for that, doing that on a per transaction basis is pretty challenging to do all 3 of those things right at the same time. And so this intents model, what we think, why we think it's so powerful is because we're kind of changing the ordering of things. A user still has their money on chain A, they still deposit it somewhere into, kind of the settlement system or an escrow system. And then as soon as that deposit happens, solvers, relayers, fillers, they're interchangeable nomenclature. They're watching for this event, and then they go and fill the user with their own money on the destination chain. So they've extended effectively a loan to the user on the destination chain. And now this is good for the user. They get filled in seconds instead of minutes in the message-based system. Now that's really good for the user. The user's happy. They paid a really small fee for this, but the relayer, the third party that has extended the loan, they haven't got paid back yet, and so they're not happy yet. And this is where this third layer of the system, this escrow or settlement system, comes into play. And what that system's responsibility is to verify that the solver did its job. It actually filled the user and performed whatever action was necessary. And then once it does that, it gets paid back. And so this happens, over some period of time. And across, it's around 1 to 2 hours. In other systems, it can obviously be different. And so this settlement piece has, across, while, we do think of ourselves at the RFQ order routing layer, we also think of ourselves as kind of a settlement system too. And kind of the components of our settlement system that we think are important are first, like this repayment mechanism over 2 hours. One of the features of Across is that we actually aggregate the verification. So we're verifying intents that were fulfilled over 2 hours and then making a single repayment to those solvers for the activity they've done for the prior 2 hours. And so we get some economies of scale here because in the message-based system, you could do the same thing, but you're, sending a message and then repaying every single fill with, the user's original deposit every time. And so that can be inefficient. And so when we aggregate the verification, we can aggregate the repayment, save a lot on gas effectively. The second thing is when solvers are, filling users, they have capital on all these different chains and they're fronting that capital to users. And the way in which they get paid back really matters to them because they have inventory that they have to manage. They have capital on all these chains. If they are filling one on one chain and then getting repaid back on another, that's a challenge for them because then they have to find a way to rebalance themselves, which is possible. And they may elect to do this, but it would be nice if, there was services available for those solvers to engage with to effectively get repaid where they want to. And that's a component of a cross settlement system where we have this LP pool on mainnet that kind of acts as this buffer to provide solvers with effectively a loan to get their repayment where they want to. And so this kind of helps solvers kind of stay balanced. They can get repaid on the chain in which they filled, so they don't have to take like cross-chain risk. They don't have to like rebalance their inventory. On the flip side, though, we offer flexibility here because solvers may elect to not do that, and they don't want to pay for this loan service. They can actually, if they have a better way to rebalance their funds, whether it be centralized exchanges or using another bridge or whatever it is, they can elect to take repayment on the origin chain, and that doesn't cost them any money, and they get to actually earn the LP fee, which would typically would have paid. So they get to increase their profitability if they do this. And so those two components we think are important to provide a lower cost mechanism for solvers to fill, while also allowing them to keep their inventory balanced so that they can continue to fulfill user intents in a sustainable way. And then kind of this third piece, I would say about the settlement part is kind of around like netting flows. And so like, if you think about it like a solver, if I have equal flow in two directions, equal flow going to chain A and then the opposite going to chain B, and I have solver and I have money on each chain, if those two things are equal, I don't actually have to do any bridging. I can fund the fills on both sides and keep my inventory kind of stable. And that's really nice. And so, our protocol allows that. It also allows that in the context of rebalancing the LP funds such that, when we do have to repay and move funds from mainnet out to kind of the L2s, we only do so when flows are imbalanced. And so that kind of affords some economies of scale and an additional efficiency in the system as well. So I'll pause there. I've been talking for a while.
Yeah, no, it's a super good wrap, and I can almost feel like Max from Everclear being like, oh, there's so many things I can jump in there, because where you're talking now is exactly where Everclear would come into the stack as well. So Max, maybe that's a really good thing. So just to recap there, like intents, for the user, it's kind of, I want to do this sort of chain A, chain B, but I don't care how you go about it doing it. Solvers take that like a job board, and then the solvers go and they do that. They front the liquidity so the user can have their experience up front, and then the solver then has all these series of challenges and complexities around like their rebalancing and managing their inventory if they're going to take on this intent for the user, so to speak, which is kind of exactly the reason that Everclear has come to be what it is today, right, Max? So if you want to speak a little bit about what's happening on the other side of the solvers, managing their arsenal, and also please explain netting to me.
Yeah, absolutely. No, it was a great overview, and I like how we are painting the full flow of the intents, right? We're getting to the stage where the user is satisfied with their money. They got their funds on the destination chain. Whatever was needed to do, they did it, and then the solver needs to figure out, as Ryan was mentioning, what's the cheapest way for me to bring my funds back to the destination chain, or start the cycle again to fulfill an intent from the users. And so at that point, basically, as Ryan was describing, the solver has a few options. One is, okay, I'm addressing two main chains. One is optimism and arbitrum, and so I can just wait until I get a request in the opposite direction, and so that will allow me to not having to do anything in the side of rebalancing, because I'm just using the same funds in the other direction. The other thing that most of the solvers are using, they're using centralized exchanges because they're easily accessible. Obviously, that incurs into a different type of risk, and they kind of jeopardize a little bit what we're doing in the pure decentralized world. Or they can let the protocol figure it out, right? The protocols might have some mechanism to move the funds back to the destination chain so they can start this thing again. Now, this is what Connects previously and now Everclear started to study a little bit. We started to look at the different flows of the different solvers, starting to understand who were these solvers and what they actually needed. And so what we noticed is two things. One is that the really profitable solvers today are the ones that have a lot of funds. And so they are okay with managing a big inventory, and they are okay with waiting on holding assets on different chains so they can use these double flows on opposite directions that might happen across the different chains. Or they use centralized exchanges. That's what the majority of the solvers do today. And so we said, okay, what would be the actual cheapest? What's the ideally theoretical cheapest way to refund those solvers? First of all, we need to understand where they want to be refunded, right? Some solver has funds on optimism and they want to be refunded on arbitrum because they want to start the cycle again. And so the cheapest way would be to find another solver who has the opposite need. So they have funds on arbitrum and they want to be refunded on optimism. And so identify this coincidence of ones and simply net these two needs together, right? We have two solvers with opposite needs. We net them together. And so the tokens don't really need to move between the different chains because we can simply give the tokens to the other solver on the same chain. And this is the cheapest and also most secure way to refund those people. And so this is where the concept of clearing comes in. Clearing is obviously something that is being used for years in traditional finance, where you can aggregate all these different needs and necessities and intentions from the solver side, and then simply net them out and figure out, okay, I just need to actually move the tokens on the same chain between solvers to satisfy what they need to do. Because the reality is that if you look at the big chains, during 24 hours, 80% of the flow actually nets out. If you for every dollar that is sent into a chain, 80 cents are actually moved out of the same chain. So this netting is actually a clear opportunity in the market that Everclear is trying to address. The way we want to do it is to building a very open and collaborative network with other intent-based bridges, any type of solvers that want to plug in, so that they can really benefit from this netting system. The more solvers there are, of course, the more coincidence of ones we can identify, and so the cheaper the whole process can be done. Now, when does it really come in? Because if you are only looking at, like, if you're Wintermute, if you're a big solver, you don't really care about this because you have the capacity to have your asset on one specific chain and hold enough and wait enough time so that you get an opposite request to move them again on the other chain. But if you are a small solver, if you are a new entrant in the market, if you're serving specifically a long tail chain, so a chain that doesn't have that much of double flow volume, you have this complexity in managing your inventory that really cuts out the smaller solvers of the market. And so the idea, the vision that we want to realize is, how do we bring in more solvers that are less sophisticated than the big market makers, that do not need or cannot use centralized exchanges? Well, this is how the clearing layer fits in. This is where we can set up these coincidence of want existing from different chains and really helping the solvers rebalance their portfolio in the cheapest way. And then once we do that, it basically cascades to every step that happens before, right? Because if you have a solver that have a very cheap price of their inventory, then they can also charge less to users. And so this is where the chain abstraction vision comes to reality, because they, the user doesn't need to notice that they're doing a cross-chain transaction. The transaction is so cheap that it becomes always a smooth experience, whether it's one chain or many chains.
Well, one of the, I hope we didn't lose you there, Max. Oh no, good. One of the things that I have surprised feels like it gets abstracted from the conversation when we talk about these solvers in the middle and clearing. Ryan, you mentioned 1 to 2 hours for repayment, and Max, what I understand from the Everclear docs, is quite similar, sort of this blocking of time periods in order to do this netting, to be able to get more transactions, so then be able to sort of look and see how you can mix and match as what's needed. For solvers, is there this, what is the likelihood that they run out of inventory on an original chain, that they need that inventory back there, but if the clearing can't happen in that time, they then would have to manage that themselves? Is speed a big part of all of this, or is it not an issue? I'll throw that to either one.
Yeah, absolutely.
Right.
Yeah. Go ahead, Max.
So definitely, right, the sooner you can refund those solvers, the better it is, right? Because they can then start using that liquidity again, whatever they wanted. So it really helps with the profitability, with the bottom line. The netting kind of scheme becomes more efficient as the network grows, of course, right? If there are more solvers, if there are more intent-based bridges that contribute to or that participate in the clearing system, then it's easier to find somebody with an opposite need, and it's easier to identify how, like, to rebalance your portfolio. Now, this works, as we were saying, for the top chains, like the chains where there is a lot of back and forth volume. Otherwise, we have a system for long tail chains that I think is very interesting, because it really allows for intent-based bridges in general to deploy on a new chain whenever at day one, basically, whenever they spin it up, because that's the biggest problem for a new chain. They need to go to all these bridges and say, hey, can you please deploy on my chain, so then we can start having this fast liquidity in and out. But at the same time, bridges need the right way to get refunded and to get refilled of their liquidity. Otherwise, the whole system doesn't work. And so we've introduced a mechanism where we wait a certain amount of time, which is flexible depending on the chain, where we try to net it out with another solver that has an opposite need. If we don't find this solver, basically what we do, we put their credit, so we put their liquidity, the need to be refunded their liquidity, on a Dutch auction. So the value of the liquidity starts at 1, let's say, and then starts to gradually decrease to incentivize basically arbitrageurs to come and say, hey, I will give you the liquidity in exchange of the small micro fee, and then they will they will figure it out. But at least you have an incentivized way for the solvers to get continuously refunded, either by the clearing system, the ideal scenario, or by these other strategies that can be programmed onto the clearing layer.
Ryan, how are you
curious
guys?
to know-
Oh, sorry, Peter, go.
Oh, sorry. I would just like a question for both of you. This is one topic that comes up frequently in our office and with other contributors we work with. And I think it's a good question. For more niche routes, solvers are more competitive, right? So you're able to, if it's like some blockchain that no one wants to support, then probably you're the only solver in that game. For networks like Ethereum and major L2s as an example, there's going to be huge competition and many routes to bridge tokens back and forth. And so what this creates is basically a race to zero in terms of fees for solvers, right? So you're all sort of competing for the same sort of reward at the end of the day. I'm curious to know, because like how we see it is probably for the sort of more popular routes, this is going to be run by large companies that are able to basically run either at a loss for a long time to claim a lot of the market, or have really good infrastructure with very low costs. I'm curious to know, how do you guys sort of see this in your eyes playing out for like the centralization of solvers longer term for these more popular routes where, you know, the value will drive lower and lower as, you know, these, like you said, like the repayment becomes more efficient on all these networks?
Yeah, no, I think it's a good point. I think it is a, you know, it's a critique that gets thrown around of intense systems in that, you know, if you have this external party that has to have capital, you know, usually if you have a capital requirement, that is a centralizing force in any kind of economic system. And kind of like what we're seeing so far is that hasn't really happened quite yet. And we think there's a few reasons. The first is if we look at like the P90, the 90th percentile size of transfers, it's around like $1,000 to $2,000. So that's not a huge capital requirement. You know, obviously you want to, you know, do several of those, but that's actually, that's still the 90th percentile. That's like one of the highest sizes you'll see. And so you can actually be a solver with relatively low amount of funds, as long as you have enough capital to withstand the volume that you're seeing or that you can win within this 2-hour period or this repayment period. And so we think that's like, that should, I think, protect against some of the centralization. The second piece is that, you know, since that capital requirement isn't huge, you can get people that are, you know, 15-year-olds in their basement who are really good at, you know, just creating a very, very efficient and fast solver, depending on how, you know, what kind of auction they're competing in. So for example, across, you know, our auction is purely based on speed right now. We're kind of modifying some things, but right now it's effectively a speed auction. So the first to fill is the winner. And any solver that attempts to fill after one has successfully filled gets reverted or rejected, and they lose their gas. And so if, you know, whoever can build a solver that runs in 1 second versus kind of our P90 fill times of 5 seconds right now, they're going to win the flow. And so if they can do that, you know, that's just a technological challenge, not necessarily a capital challenge. And so those two reasons, I think, you know, there is protection against that. Now, as we go up larger and larger sizes, I do agree that there is a centralizing factor. But even with the sizes that we support right now, you know, based on transfer share, like the distribution of fills amongst, you know, we call them relayers, it's not, you know, I don't think any relayer owns more than, let's say, 20%. And we probably have like 10 to 15 that are very, very active, and then like 15 to 30 overall that are in the space, maybe still trying to figure it out. So, and I think we're still early days. And so I do think the big players will come in. Maybe they'll operate at the larger sizes, but again, the larger sizes, they might be the largest percent of volume, but they're not the largest percent of users.
That's really interesting, because when we start to think about like the big values, you're not going to see people handing that trust of millions of dollars in a transaction to a solver, right? They're going to want to manage that, and it makes sense to micromanage that and have sort of your finger on the pulse. the whole way. So what you're saying is, I guess, alluding to the fact that when we have these like consumer apps that are going to be like high transactions, like people are going to be issuing transactions left, right, and center, it makes sense that solvers will only have to do like micro value upfront. And then the speed. Can you speak just a little bit on like the state of solver networks today? Because as I understand it, across you're running your own solver network. Is that right? What's the state of solvers right now? What's the biggest challenge to get more solvers into the space?
Yeah, so there are, around 15 to 30 active solvers in the across network, actively filling on across quotes. I think the biggest challenge right now is, there needs to be a standard interface for solvers to go and look at an order flow source and be able to like immediately recognize what to do with that order flow. And so that like it has to be structured the same. And then on the opposite side, when they're going and filling, we talked about this settlement aspect where they need to get repaid. So they need to interact with a settlement system that's fundamental to kind of what we're doing. And like that interaction or that interface needs to be standardized as well. And so what I'm kind of alluding to here is I think both interfaces of who the solvers are talking to, whether it's the request for quote mechanism or the settlement mechanism, they need to be standardized so that more solvers can support more applications with more order flow. And this isn't just like a cross order flow. This can be any order flow if it's structured in a similar way. Then, a solver can look at it, know what to do with it, and interact with the settlement system and know what to do with it. And one of the things that we're working on, and we released it or announced it back in April, was a standard we're working on, ERC 7683. And we're working on that with Uniswap and One Balance participated as well. And so like we're kind of eager, we're still kind of working on it and kind of figuring out the last final touches, but we do think we're close to something here. And whether it's this or it's another thing, we do think that the standardization process needs to occur so that there's less work on relayer or solvers to get started in terms of processing order flow and settling the order flow.
100%. I think every time I hear standardization, I just hear this is another solution to fragmentation, right? Because if we create all these different standards, then we'll have these like mini chain abstracted worlds. Everyone makes the joke about ag layers, and then we're gonna need ag layers for ag layers, right? So it's really good because we're doing standards for data transmission, these standards for solvers, and I think at the end of the day, what that means for a non-Web3 dev coming on chain, they're just gonna be sweet. This is how these are done. It's just much less of a headache. Max, I want to throw over to you because I was reading through the Everclear docs. I was listening to some pods this week, and I really like this angle of programming how you get rebalanced or how on what chains you want to get rebalanced. Can you speak a little bit to the programmable nature for solvers?
Yeah, absolutely. So, I think we are aligned here. The ideal scenario for a new solver is that the overhead that they have to put into managing, the system is as reduced as possible, and so they can be more profitable. That there is less maintenance that is required. So this is where all the work has been done around the second half of the chain abstraction stack is being worked on. The standards that Ryan was mentioning is a great example. Also, all this network of solvers that are popping up are really interesting. I think the ENSO, the Kalani networks, they will help standardizing and making it more accessible for people to run the solvers and to join the different networks. And then there is the strategic part of the rebalancing, as you were mentioning. It's interesting because if like a user that wants to bridge, right, to one chain to another one, it has really very specific parameters that they want to be satisfied. Security, for sure, the cost, and then the speed. But for a solver, these kind of dimensions are much more diverse and much more variegated, because a solver might be wanting to be refunded on different chains, on different assets, right? They might not be as specific as a direct line, as a strict line as a user. And so this is where we as Everclear, we're trying to give the opportunities to solvers and bridges to craft their own strategies depending on where do they see the need on the chain to be refunded, but also what assets they are expecting to be refunded, to be refilled with. I'll give you an example. In the case of USDC, for example, right? Some more centralized assets, you have the options to actually ask Circle to burn and mint an asset across the different chains, right? So that's the cheapest way to actually move USDC across the different chains. And so if you're not constrained by time, you can set up as a strategy that you want to use other protocols to move those assets across the different chains. So what the clearing layer wants to do is to really enable their builders to create a strategy that fits. On one side, the chains where they want to be refunded, it tends to be the destination chain where they use their capital, but it might also be like, hey, I'm noticing a trend of flow towards a specific cluster of chains, bring my capital back there. Or I want to actually be focusing on specific assets. And so the clearing layer will look at, okay, who has the right to mint those assets, for example. Let's ask them an authorization to burn and mint the assets so they can be refunded in the cheapest way on the destination chain. Or rather, using these other strategies around the netting system, using Dutch options. With the beauty of it is that being a fully programmable platform, you can customize it according to your needs, which are, as I was saying, more diversified than a normal user request.
Amazing. I'm loving this. I'm hearing this more and more in the space about like programmability. In the last 10 minutes before we wrap up at the end of the hour, I really want to get this kind of comparison between what it was like for a dev to build 2 years ago in the space or 3 years ago. Let's go like when people were trying to launch apps on different ecosystems and it was just so difficult and the consumers didn't come in, right? So Ryan, I was curious before, I actually want to throw this to you. What's the experience like for an app dev when they were building with a traditional bridge versus what they're doing on a cross now they have access to your tools?
Yeah. So I think like, day one, when L2 started popping up, applications, if they wanted to access users on those L2s, they just had to deploy new instances. And that meant a whole nother, instance to manage, liquidity to manage, which fragments their liquidity if they already had some on a single chain. Probably additional, deployment costs, monitoring costs, DevOps costs, all of that. And so all of that in pursuit of users, that would be one option. The alternative option would be they just want to access cheaper block space and they just deploy on an L2. They're a new app, so they go to the cheapest one. But then, on day one, back when there really weren't bridges or they weren't tightly integrated, they were kind of just expecting users to show up. Expect the user to figure out how to get to my application, get to my chain, whether that's using the canonical bridge or another bridge, or using a centralized exchange to, withdraw into that chain. They were trying to just, I think like the expectation was that users had to figure it out. So that's where we started. I think where we're at right now with Across, and we have kind of two products aimed at like this first step, where applications can directly embed kind of a bridging interface inside their application to move funds to the chain. They can also embed a bridge into their application actions. And so this is why I was talking around like you can move value and then also execute an action. And where this comes into play is like an app dev could, wrap effectively all of their protocol actions, all the buttons on their UI that interact with their contracts. They could wrap that with a bridge beforehand so that a user could take any action on that application from any assets on any other chain that Across supports. And so those two things are live today. But this still doesn't simplify two things. The first is it doesn't simplify the user UX of knowing what assets are on what chain. It's also, relatively complex for app devs to do this. And so, we're trying to think and trying to figure out like, where does it make the most sense for this kind of abstraction to occur? Is it at applications? Is it at wallets? And so we're exploring both of those options and trying to see what it would look like for that abstraction layer to live in the wallet instead of the application. And then the app devs don't have to care. They get abstraction by working with a wallet that uses some sort of abstraction module inside of it. But then you get into things like, well, is that putting too much power in the wallet? They get to control all of this order flow. Is that a centralizing force? All of those things, all of those questions start to pop up. So it is very much, to us, we're exploring it, but we think we have a long road ahead to kind of figure out how the pieces fit together. But right now, even today with our existing functionality, you can achieve some level of, a user can take an action in an application and use it from assets on another chain. We're not completely abstracting away the chains, but the user can at least do that action without like having to use a bridge independently of the application.
Rome was not built in a day. That's what I always remember here. Is like people, I think I look at CT, and everyone wants that, like, speak to your AI agent in your phone. It will manage your portfolio and it'll do everything for you. You just, bellow out a few instructions and it'll all happen. But I think this is really important, what you're saying, to just frame for the industry that this is going to be a process, and we have to get to, like we said at the start, we're coming full circle now. We have to get to here, this point, and this point has to work, and we have to test it, and we have to see kind of what are the trade-offs, what are the other problems that we don't see right now, solve all of that, and keep stepping forward as an industry. So it's a very exciting time for chain abstraction. Max, I want to give just to you as well, because I want to understand a little bit before we wrap up. How much does an app dev need to know about clearing, or what's happening in the background with your toolkit? How simple is it just to get the benefit of Everclear without really having to necessarily understand all the plugins that are going on here?
Yeah, hopefully an app developer will not need to know about Everclear. Like, the idea is that we can also abstract that part of the stack for app developers, so they can only focus on bringing the right experience to users, right? That's what we want to do, right? This overhead of, again, thinking about all the deep part of the stack, the technological stack, ideally they shouldn't care about it. So Everclear wants to do one thing very specific, which is helping to coordinate the rebalancing of this liquidity across the different chains. And so the users that we see for Everclear are solvers, the users that we see are other intent-based bridges, centralized exchanges as well. We're seeing a huge demand for these guys to actually rebalance their liquidities. And for them, we are trying to make the life as easy as possible, right? If you want to build potentially a new intent-based system, a new network of solvers, we want you to just plug into Everclear. You express another form of intent, which is, hey, here's my liquidity, here is where I want to be rebalanced, and then Everclear will manage the overall shuffling and the computational part to see how do we get to the tokens in the cheapest way, even if it takes a little bit more time than what a user would require. And I think we should all strive to do that, right? Like, focus on your piece of the stack and be very collaborative with the other players in the space, because at the end we are all working towards the same goals. Ultimately it's building a better internet, and so these are small pieces in that journey. But I think it's all coming along together. I'm extremely optimistic now and excited in seeing that it's finally the flow. For a developer, has become easier and easier to be in these chain abstracted apps, and then now they can focus on, okay, what do I actually build that creates utility, that people actually want to use, rather than, okay, maybe I should maybe I should try to look on a layer 2 that is actually natively composable because it has shared sequencing with other layer 2s. This at some point, yeah, we have to have specialization, and we have to detach the infrastructure from the app layer and the user ultimately.
I think that's like the perfect wrap, and it's something that I'm learning from the camp series here right now, is like, people want to be bullish on apps. We all want to be bullish on apps and app experiences, right? But in the meantime, we should all get super bullish on the infrastructure that's going to power that end state. And it's an absolute pleasure to hear from you, Max, from Everclear, and Ryan from Across as well. Even though Across you have a user-facing app, but like what's going on under the hood is just super powerful, and very excited to see your traction continue. Very excited to see more and more people plugging in through Hyperlane into Everclear and through that system. And super excited for the SEDA mainnet coming up at Q4 as well. So we'll be able to put the product foot on the pedal and go ham from our end as well. I'm going to wrap up here as we have a hard stop at the end of the hour. Ryan, thank you so much for your time. Max, for you as well, and Peter for jumping on. Appreciate all three of you. Thank you.